Good day, everyone. I am Natalia Marie Anadon Garcia from grade 12 Dalton. So, in today's topic, I'll be discussing about amplitude, frequency, angular frequency, period, displacement, velocity, and acceleration of oscillating system. So, our main objective for today is all about understanding the relationship of amplitude, frequency, angular frequency, period, displacement, velocity, and acceleration, and oscillating system. So, first, go to our topic. So, what is periodic motion? So, it is a motion wherein it is repeated in equal interval of time. So, an example of this is a rocking chair, a bouncing ball, a swing in motion, and the Earth revolving around the sun. So, let's go to our topic already. So, what is oscillatory motion? So, oscillatory motion or oscillatory system is a type of periodic motion where the object moves back and forth repeatedly, returning to the initial state after a period of time. So, an example of this is swinging pendulum. So, when it is reached to the vertical position, so there is no need for its acting up onto this object. So, yeah, that is the example. And let's go to this. What is amplitude? So amplitude is the maximum displacement of body from its equilibrium position. So in short, it's simple. So we can say that it is shows how far the object moves from the center. So an example of this, if a swing goes higher, the amplitude also goes higher. Next is period. It is the time required to make a complete to and fro motion. So once complete to and fro motion, so it is already called cycle. So period, it is represented by the letter T. So T is the time needed to complete one cycle. So in short terms, it is like, for example, since T is the one that is represented time, so it is needed for to complete a one complete cycle. So meaning, so one full back and forth movement. So it has a unit of seconds, and the formula is T equals 1 over F. So the longer the period, the slower the motion. Next is frequency. So frequency, it is the number of cycle per unit. So the SI unit of this is the hertz, abbreviated as Hz. So it is the one that tells how many cycles happen in 1 second. So the formula of this is F is equal to T. So it is just like the vice versa of the first one, the period, because the period formula is T is equals 1 over F, while as for the frequency, it is F equals 1 over T. So frequency, so it tells how many cycles happened in 1 second. So this means if something vibrates faster, so the frequency is higher. And then next is the angular frequency. So it is the rate of change of the angle of an oscillating system. So it is represented by a Greek letter omega, which is like a W, and it is measures how fast an object oscillates in terms of angle per second. So it is calculated with use of the formula. So the one is Greek word, the letter omega is equals 2 pi RF, or the omega 2 pi over T. So and the unit for this is radians per second. So it basically connects circular motion and the oscillating system. So who among you still remember the circular motion? So by this, the angular frequency, it is the one that connects the two of them, the circular motion and the oscillating system. Next, we go to the displacement, velocity, and acceleration. So first, what is displacement? So displacement is a position of the oscillating object at any given time relative to its equilibrium position. So from this, or let's just say the three quantities itself. So it is represented the expression. So x quantity of t equals a sine quantity of omega over t. So next is velocity. So it is the rate of change of displacement with respect to time. An equation for this is v quantity of t equals negative A omega cos quantity of omega over times t. So next is maximum velocity. How to find the maximum velocity? We have the Vmax equals A omega. Next is the acceleration. So is the rate of change of velocity with respect to time. So the equation for this, in order to find the acceleration, is A is equals negative omega squared cos quantity of omega times t. So the maximum acceleration is A max equal A omega. So in this, so these three quantities always change because of time. So that's where you need to remember. The displacement, the velocity, the acceleration is always change with time. So next is, so you have here the example. So by observing the reference circle, we can relate time with the movement of the ball along the y-axis. So let amplitude A be the hypotenuse, distance y be the opposite, and the angle be theta, which is equal to the omega t. From the set given, we can get the relationship of amplitude to frequency. So formula for on this is, so should, as you can see in the picture, so we have the formula, the sine theta, sine quantity of omega equals y over a, or you can say that y equals sine quantity of omega times t. Then the next is how to convert the angular frequency to frequency. So we can use the y is equals a times sine 2 pi ft, or the w is a 2 pi f. So in this photo, or in this, it is how explains how displacement depends on the both amplitude and angular frequency. Next is, by using this equation for the previous slide and differentiating it with respect to time, we can get the relationship of the velocity and frequency. So we have here y is equals a sine omega theta, v equals dy dt equals a times w cos omega theta, or we have here, so we have here how to convert angular frequency to a frequency. So we have v is equals a asterisk or times 2 pi rf cos 2 pi rft. Then by using the equation this above and differentiating it with respect to time, we can get the relationship of acceleration to frequency. So we're already done with related to frequency. Now we go to acceleration and frequency. So in order to find it, we use the d squared y over dx squared equals minus a times omega squared sine omega t. A is equals to a equals negative omega squared y. So since w 2 pi t, so we have a is equals 2 pi t to y. So the 2 pi t, so it is w. So our formula for this is a is equals negative quantity of 4 pi squared over t squared y. So next is convert angular frequency to frequency. We have a is equals 2 pi rf squared. So the equation of period are represented by time. So t squared equals 2 pi r squared over a times y. Or we have this, it is the relationship period t to accelerations and displacement. So t is equals 2 pi over square root of negative y over a. So I have here an example solving. So when an amplitude is 16 cm and the ball bounces back and forth in a span of 4 seconds, find a frequency and angular frequency, b acceleration and velocity at x minus 16 cm, and c acceleration and velocity at x minus 10 cm. So what is the formula we use in frequency? So as we all know, the formula for frequency is f is equals 1 over t. So we have here our frequency is, we have 1 times how many seconds we have is 4. So 1 over 4 is equal to 0.25 hertz. Why hertz? So based on the explanation based on the explanation I said earlier, so frequency should be represented in hertz. So next we will go find the angular frequency. So omega is equals to 2 pi RF. So we have the 2 pi times 0.25. So 2 pi, we all know the value of 5 is 3.14. So 2 times 3.14 times 0.25 is equals to 0.5 pi radian s. Next is the acceleration. So acceleration. A is equals negative w squared x equals negative 0.5 pi radian per second squared, or 6 times 16 centimeters. So the answer will be A is equals negative 4 pi squared cm s squared. So velocity is equals A omega cos omega t, then the wt is equal to sine negative 1 y over a. So a sine negative 1 equals to 16 times 16, so it equals to 90 degrees. So we will use the formula, which is V is equals A omega cos omega t. V is equal to 16, 0.5 pi cos 90 degrees. So, asan gikan ang 90 degrees? So, you have to divide t. The formula for it is sine negative 1. So, y over a. So, our value for y is 16 and our value for a is also 16. So, 16 equals 90 degrees. So, we have here 16 times 0.5 pi cos 90 degrees. So, it resulted in 0 centimeters squared. Next is how to find the acceleration. So, the formula for acceleration is A is equals negative y w squared, x is equals to the value of our negative, or w, is equals to 0.5 pi radian per second squared, and then we have this times am. So the answer for this will be A negative 4 pi squared cm squared. So we have also here another velocity. So in different na, so another. So here we have the A omega cos wt equals sine negative 1 10 over 16. The answer will be 38.68 degrees. So V is equals to 16 centimeter times 0.5 pi radian per second cos 38.68 degree. So the answer will be 19.62 cm per second. So the key quantities for this is the equilibrium position. It is known as the resting position. It is a position assumed by the object body or when it is not vibrating. Amplitude of variation is the maximum displacement of the body from its equilibrium position. Period, the time required to make a complete to or fro motion. Once complete, two and more motion it is called cycle. So period is really important in order to perform a one whole complete cycle. Next we have frequency. So frequency is the number of cycle per unit. So it is has the SI unit hertz. So 1 hertz is equal to 1 cycle per second. Next is the angular frequency. So it is measured how quickly something oscillates in radians per second. So we have also the last is displacement. It is a position of oscillating system at a given relative to its equilibrium. Velocity is the rate of change in displacement with respect to time. And lastly, we have acceleration. So it is a change rate. It is the rate of change of velocity. So that's all